All right, so here we're going to compare substitution and integration by parts. So I might do substitution first for the first one. So we've got 0 to 1 x, x minus 1 to the power of 5 dx. So a good substitution, you could use u squared or u. Sorry, in this one you'd use u, yes. Let u, I'm looking at another one, let u equal something like x minus 1. So du would equal dx. We'd also put the limits in. So if I sub 0 in, I get 0 minus 1 for u, and 1 in, I get 0 up there. All right, so my x, so if I make the x the subject here, I will get u plus 1. So I'm going to have u plus 1 for that x. For the x minus 1 to the 5, I've now got u to the 5. For the dx, I've now got du. So you can see clearly that that will just be u to the power of 6 plus u to the power of 5 when we multiply that out. So we're just going to get u7 on 7 plus u6 on 6 when we integrate. And that we're subbing in 0 to start with, so when we sub in 0 we get nothing, minus when we sub in a negative 1 we're going to get a negative 1 on 7, negative 1 to 6 is positive 1, so positive 1 on 6. Alright, so then you could do that in your calculator, or you can make a common denominator of 42 and see you'll get the minus 6 plus 7, so you'll get and then you've got the negative out the front, so don't forget that. So I've got a negative 1 on 42. Alright, so that's by substitution. Let's see if by parts is any quicker or not. So I do, let's see if that is, yep, there we go. So by parts, our integral would equal, so we could, now if you integrate the wrong one, you could still do it, but it takes even longer. So the one to integrate here would be the x minus 1, so now to the power of 5. So it becomes to the power of 6 divided by 6. We're going to leave the x. Now we've already integrated the x minus 1 to the power of 6 on 6 there. And then we differentiate x, which just becomes 1, which makes it a lot nicer. And of course, this is a definite integral. All right, so when we sub 1 in, you can see we're going to get 0 in the x minus 1 bracket. And when we sub 0 in, we've got times 0 there. So the whole front will be just 0 minus 0 for that part. And then if we look over here now, we've got minus 1 on 6. If we integrate, we get x minus 1 to the power of 7 on 7. I'm going to do this part, 0 to 1. So here we've got minus 1 on 6. When we sub in 1, we're just going to get 0. When we sub in 0, we're going to get, so we're minus. When we sub in 0, we're going to get negative 1 to 7, which is negative 1 on 7 there. So you can see that is going to become a plus here, but we've got a minus out the front, so we've got minus our 1 on 42. So you decide which method you like better, and it really doesn't matter. So they look about the same, although personally I like the substitution there, but it's up to you. All right, so let's try B. We'll do the same thing and see which one's better. So let's just move this over a touch so we can see B. All right, so again, if we're doing a substitution, we might let our u be x plus 1. So in this case, if you want, you could do u squared because it's under the square root. So up to you. I don't usually do a u, so I'll do a u. All right, so then we get du dx. Again, our integral, if we sub in x equals 0, we will get 1. If we sub in x equals 1, we will get a 2. Okay, so first of all, we've got an x, and you can rearrange this. So our x is u minus 1. So I'm going to put that in first, u minus 1 for our x. Square root of our x plus 1, so that's our u to the half. And our dx is our du, so that's all fine. Okay, so when we go about doing this one, we actually just integrating u to the 3 on 2 minus u to the half du, just expanding that out. Okay, so add 1 to the power, we get 5 on 2, divide by 5 on 2. Add 1 to the power, we get 3 on 2, divide by 3 on 2. So 1 to 2. So if I put 2 in here, you can kind of see here, you can do it different ways. I could just add, I've got another 2, so I could make that, instead of 5 on 2, I could make that 7 on 2. On 5, minus, and there's another 2 out the front here, so instead of 3 on 2, I could make it 5 on 2. So that's if I put the 2 in, minus, if I put the 1 in, I'm just going to get 2/5 minus 2/3. Now, again, I like to do this in without the calculator, but really you can just put it in the calculator. But you might want to first just take out a square root 2 out of this term. It might make it easier to start with. So if you did take a square root 2 out, you would have 2, so you're taking a 1 out there, so you'd get a 6 on 2 left, which is 2 cubed. And here, the next one would be 4 on 2, so that's a 2 squared. Because we want the exact answer. And then you just go ahead and do it. So for example, this one's going to be on 15, and you're going to get 3 2s are 6 minus 10. 6 minus 10 is minus 4 15s. So, and it's a minus there. So now you can do that and get an exact answer. And you're going to end up with 4 on 15. From the second term, you're going to get the positive 1. From this first term, you're going to get that root 2. All right. So let's look at doing it using integration by parts. So what we could do is, so again, just make sure you're integrating the right part. So we're going to integrate the x plus 1 to a half. So x plus 1, add 1 to a half, and we get 3 on 2 divided by 3 on 2. And we're going to keep the x term. And then we're going to minus the integral. So we've still got all that stuff there. And of course, when we differentiate the x, we're going to get 1. But I've still got the 2 on 3, so I'll put that out the front though. There. And it's 0 to 1. If we want, we can go over here and go 0 to 1. Now you can see out the front there that if I sub the 1 in, I'm going to get 2 to the, yes, if I sub the 1 in. So if I sub the 0 in, you can see from the second times x here that I'll just get a 0. So I only have to sub the 1 in, and you'll see you get 2/3, and you also get a 2 to the 3 on 2. Okay, minus, all right, so if I go over here, I've got the 2/3. I can add 1 to the power, so I've got 5 on 2 divided by 5 on 2. And of course that is between 0 and 1. All right, so what have we got here? We could do it all different ways again. So let's go 2 to the 5 on 2. Pity I can't read my writing, on 3 for that first term. Minus, I might actually put the 2 squared on 15 out the front. 2 squared on 15, and then just look at the x plus 1 part. So I'm going to get 1 plus 1 to the power of 5 on 2, so 2 to the power of 5 on 2, minus, and then I'm going to get 1 to the power of 5 on 2, so that's just 1. All right, so putting that all together again, besides the square root 2 and putting that out separately, so for instance, in this first term, you can see I could take out a square root 2 for that first term, and that gives me 2 squared now. 4 on 2 is squared, so 2 squared is 4, so I get 4 3. I'll just leave that there for a second. Over here, I could take out a square root 2 for this term, kind of putting that together. There's a square root 2 there, And again, if I take 1 from that 5, I've got 4 on 2, which is squared, so that's a 4. And out the front, there is a 4, so 4 fours. We've got a 16 there, so 16 on 15 for that second term. Then the last term, minus minus is a positive, and we've got 4 on 15 there. Okay, so again, looks like it's a nice idea to take out a 4 on 15. If I do that, just taking the last term, that's 1, which we want, and looking at these two other terms, if I want the difference, I've got actually what you can do if you don't have a calculator, split this 16 up into 4 fours and think you've got one lot of root 2 4 on 3s. Actually, if I make that a 15, the other thing you do is make this a 15, so times by 5 and make that a 15. And you've actually got 5. There we go, so now it's the same. 5 lots of root 2 4 on 15s minus 4 lots of root 2 4 on 15s. And the 4 on 15s out the front, so really we've just got 5 lots of root 2s minus 4 lots of root 2s, which is 1 lot of root 2. Of course, you can get your calculator to help you with that. Okay, so up to which is easier. So with all those square roots, we have to deal with them for both, so it's probably not so helpful there. Either way, let's look at C. All right, so this time, just to do something different, oops, because it's under the square root, I might let u squared equal 4 minus x. Then we get 2u du is minus dx there. All right. So let's see how that goes. Again, if I want to substitute 0 in for x, I get 4, and square root of 4 is 2. Sub in 4, 4 minus 4 is 0, square root of 0 is 0. So I get from 2 to 0, x being 4 minus u squared. If I rearrange this part, x is 4 minus u squared. So I'm going to sub 4 minus u squared there. Root 4 minus x is just now u. And then dx is actually negative 2u du, right? Negative 2u du. All right, so if we put all that together, what I might do is put the 2 at the front, and in the negative, I can just change these limits from 2 to 0 to 0 to 2. That takes care of the negative. And then I've got a u squared timesing by these brackets. So if I just undo that, I've got 4u squared minus u to the 4 in my brackets. So that should be okay. So 4u cubed on 3 when we integrate, and u 5 on 5 between 0 and 2. Now you can see that when I sub in 0, I'm going to get 0. So all I'm worried about is subbing in the 2. You can also see that I'm going to get u, I could factorize by u cubed, which is 2 cubed, which is our 8. So we could actually do that as well. Whether to do that now or not, I don't know. So 2, if I take out a u squared, I'm timesing it by 2 squared, then what's left is 4u, so 4 2's 8 on 3. I've taken out a u squared, so I've only got a cube left, so 8 again on 5. All right, I hope I've done that right. So again, you could just use your calculator here. You'll end up getting 128 on 15. All right, so let's try using by parts here. So if I were doing it by parts, again, what we're going to do is take the 4 minus x to the half. We're going to integrate that one. 4 minus x to the half. If I integrate, I'm adding 1 to the power, dividing by that power, and inside you can see I need a negative 1 as well, so I'm going to put a negative there as well. And then just leave the x. All right, so just put it there so we can see it. Minus, except there's this minus down here with the minus 3, so that is going to become a positive. I'll keep the 2/3 outside. I've got 4 minus x to the 3 on 2, and I'm differentiating that x so it becomes 1 dx. Okay, so again, this one is between 0 and 4, between 0 and 4. All right, so I'm going to actually keep that 2/3 out the front before I sub in. When I sub in that 4, I'm just getting a 0 in that bracket. 4 minus 4 is 0. So I'm getting a 0 minus. When I sub the 0 in, I'm getting a times 0 for that x there. So either way, I'm going to get a 0. So that's nice. Gets rid of that one for us. So let's have a look at this one. So 4 minus x, we are adding 1 to the power. So 5 on 2 over 5 on 2, and we need a minus as well because it's a negative x in that bracket. All right, so 0 to 4. What I might do again is pull out the 2 and the minus 5, so I'm actually getting a minus 4 on 15 there. Then I've only got the 4 minus x to the 5 on 2 to worry about. Now 4 minus 4 again is 0, so 0 minus. When I sub in the 0, 4 minus 0 is 4. So square root of 4 is 2, and 2 to the power of 5, I think is 32. I can just put 2 to the 5 as well. And you can see it's a minus minus, so it's going to become a positive. So again, 32, well, yeah, so I will get the positive 128 over 15, which is the same answer as before. So you just have to decide what you like better. Often in most of the exam, it won't say how you have to do it. It'll just be, integrate. So you can choose which way you'd like best.